547, we're joined now by Professor Paul Williams, Royal Society University Research Fellow in the Department of Meteorology at the University of Reading, to talk about clear air turbulence. Good morning, Professor.
Good morning, Bruce.
First time I heard about this was just this week, and it was an aircraft that, wow, I don't know if it took a dip, but they had coffee all over the ceiling. Is this a recent sort of development, clear air turbulence, or has it been around forever?
It's been around forever, but we think it's getting worse. We call it clear air turbulence just to distinguish it from the other main kind of turbulence, which is turbulence in clouds. And of course, the pilot can see that. There's within clouds, the warm air is rising up through the atmosphere, and there's colder air moving down, and those vertical motions push up and down on the wings of the plane, and that causes turbulence. But it doesn't tend to injure people in clouds just because the pilot knows it's there, the radar on the plane can detect it. But there's this other kind of turbulence, the clear air turbulence, that's invisible. So it tends to come out of the blue, particularly at that portion of the flight, the cruising phase, where the passengers tend to be unbuckled or moving around the cabin. So this is the kind of turbulence that really does cause those hospitalizing kinds of injuries that we've seen this week.
Is this where we might see a plane drop a couple of thousand feet in one of these pockets, or is it just going to push upwards?
It can go both ways. It certainly might feel like it's dropped a couple of thousand feet. I think that would be very rare. I think it feels a lot worse than it is. I think tens of feet, maybe low numbers of hundreds of feet on a very bad day in extreme turbulence. But it can. If the plane moves down and you're not seatbelted, then obviously you move up and you strike the roof of the plane. If the plane moves up, then you can be kind of thrown to the floor. So both of those things can happen and can cause injuries.
So there is no way to detect this, or are we working on some sort of system to detect it?
Scientists are working on a system, but it's still very much in the experimental phase. It involves shining some ultraviolet laser light out of the front of the plane and looking at the reflected light. It turns out that the kind of density perturbations in the atmosphere that are the signature of turbulence can reflect this laser light back to the plane, oddly enough. So there have been some test flights done, and it does indeed seem that we might be able to detect clear air turbulence, maybe 15 kilometers ahead of the plane. The problem with the technology is it's very expensive, and that's why it's not being used yet. Also, it's very heavy. It weighs a lot, and just having all of that weight in the front of the plane is not something that the airlines really want to have to do, because it involves more fuel to keep the thing in the air.
Are we seeing more incidents?
Yes, it looks like we're seeing more incidents. I've seen some accident statistics which suggest that the number of people being seriously injured by turbulence has increased by a factor of 5 since the 1980s. That a part of that increase is simply because there are a lot more of us flying these days.
Right.
So that's part of the reason. But even after you correct the figures to remove that effect from the growth in aviation, there's still been something like a doubling in the serious injury rate. And my studies, scientific studies, have been suggesting that climate change might be behind part of that increase.
Think we're going to see another increase?
I think we're going to see a gradual increase in the strength and the frequency of occurrence of clear air turbulence encounters going forward over the coming decades. There's a lot of variability in turbulence statistics. It does go up and down a lot from one year to the next, but superimposed on that variability, we have good reason to believe, plenty of evidence building up now, that we'll see a long-term trend, upward trend in the strength of turbulence in the atmosphere. Whether that translates into an increase in the number of injuries depends on how we choose to respond to it. We could, for example, invest research money into improving the turbulence forecasts, and then an increase in the strength of turbulence wouldn't necessarily imply an increase in the number of injuries. So there's lots of different factors going on in this mix.
Does altitude have much to do with it? For instance, if you flew at a lower altitude or a higher altitude, would you be? Could you avoid it?
Potentially, although we do know that the average patch of clear air turbulence is about 1 kilometer thick. So you'd have to move altitude by a kilometer, at least a kilometer on average, to get out of that turbulence. So yes, the first thing a pilot will think of doing is changing altitude, but that doesn't always fix the problem because of the magnitude of the altitude change that would be required.
So I would think the take-home lesson here for the passenger is always have your seatbelt on.
Absolutely, Bruce. And I didn't used to follow the best advice, actually, when I fly a lot, and I used to be a bit relaxed about things. But since I've started doing this research and I've seen the statistics now, literally, if you keep that seatbelt fastened, you're virtually guaranteed not to be injured, even in the most severe of turbulence. So, yeah, do what the pilots do. Keep your seatbelt fastened at all times.
Yeah, that's good advice. Do what the pilots do.
Absolutely.
Okay.
Yeah.
All right, Paul, we appreciate the explanation. Thank you very much.
Great to talk to you, Bruce. Thanks.
Professor Paul Williams at the University of Reading explaining clear air turbulence. It looks like we may be seeing more incidents. Keep that seat belt buckled. 5:53.